Is Denny Lee, the great engineering folks from Scribd, to talk about specifically replicating data into the cloud. To give you a little context, my name is Denny Lee. I'm a staff developer advocate here at Databricks. I've been working with Apache Spark since about 0.6 and Delta Lake since probably 0.3 or 0.2. And prior to that, I was at Microsoft. One of the projects that I was part of was Project Isotope, which brought Hadoop into Windows and Azure. So you can partially blame that on me, so my apologies. But nevertheless, the key context here is not so much about myself, but it's actually about our engineering friends here at Scribd. So let's start with Alexander. Alexander, why don't you introduce yourself first?
Hi, I'm Alex Kushner. I'm a data architect here at Scribd, and I'm a tech lead on data engineering team. Prior to Scribd, I had my professional experience in various domains of software engineering. I've built websites, mobile apps, distributed systems, but for the past 5 years, my focus has been big data, and I am a big fan of Spark and all things Spark. So.
Awesome, awesome, awesome. Okay, perfect. Well, then, hey, the other cool person that we want to introduce is Max. So, Max, why don't you go ahead and introduce yourself to the crowd here?
Yes, hi. I'm Max from Ukraine. I'm working as a big data engineer for past 5 years and mostly focused on Spark, Delta, and Scala. That's three core technologies that I like and trying to use it for data processing.
Perfect, perfect. Okay, well, this is a great start, great set of introductions. So let me go ahead and start in terms of when we're talking about replicating data to the cloud. Let's get some context first, okay, about why and what are the processes that Scribd had to go through to replicate data to the crowd. So, Alex, I think I'm supposed to start with you, but Max, please definitely chime in if you have any thoughts or color commentary. Alex? Where was Scribd coming from? What were the legacy systems that you originally were starting with, and then we'll eventually discuss why the transition to the cloud.
All right. So where are we coming from? When we took on the adventure of this cloud migration, we started with what I would describe as a standard Hadoop on-premise infrastructure. We had a large cluster which was hosting our HDFS-based data lake, and the same cluster was used for the purposes of nightly compute, ad hoc development, and etc. So so when we decided to move to the cloud, we wanted to avoid this tight coupling between data and compute, and in order to achieve that, we figured out, well, we need to have a way to get the data over to S3 in our case, and we started with that. But before we could do it, we wanted to solve some problems that we had in our existing data lake. The problems that we were facing were due to this natural, I guess, organic growth of our data lake, and we had great variance of storage formats. Any storage format you can think of, and you probably already forgot about exists, we had it. We had lots of tables with small file problems on them. We have variance in our file sizes for the same tables. We also had variance in our compression algorithms. We even had tables that used 3 different compression algorithms for different partitions that they had. So yeah, this is where we're coming from, and we didn't want to bring all this legacy along with us. We wanted to use this as a true upgrade opportunity and move into a much cleaner, much more uniform storage.
Wow. Okay. So there's a lot to unpack here, actually. So let me go ahead and dive into some of those issues, just because, we could probably even just go on for a couple hours just on all these issues. But let's start with the concept of when you were working on-prem with your Hadoop environments, right? You noted the fact that you wanted to actually have independent compute and storage, that you wanted to decouple those two concepts. From your perspective, like, why was that so important for you? Was there like particular batch processing? Was it because you were intermixing different types of workloads? I'm just curious, were there a particular set of factors that resulted in you deciding that this decoupling was so important for you?
There was two main factors in this. First one was the way our clusters were configured. We couldn't grow our storage without growing compute along with it. So if we wanted to add HDFS space, we were paying for storage and for additional CPUs and memory. We didn't really have the workloads to fully utilize our compute resources 100% at the end of the life of that system. So we had much more CPU and memory that we could have used. Another problem was that we have a lot of jobs that run in parallel on our infrastructure. And the nature of those jobs is they do a lot of shuffling. It's a classical business analytics and data science workloads where a lot of data is joined, grouped, etc. So because of that, we couldn't have workload isolation. And our biggest resource contention was actually network I/O. So all of these jobs were fighting over cluster intra-network I/O, intra-cluster network I/O, basically. So yeah, we wanted to scale our data independent of our compute, and we wanted workload isolation. That's really why we moved away from that architecture.
Oh no, that actually makes a ton of sense. I actually, in my past, one of my past environments, we had I was trying to convince our operations team that we needed to set up separate routers for our Hadoop cluster, but they decided that they didn't want to do it. So when we were running a very simple sum sort query, we basically were doing a DDoS attack into our internal network. So yes, completely grok where you're coming from. So yes, network isolation and the fact that you weren't utilizing the full compute clusters. But then I guess because of all of these shuffles that you're running, like the joins, the groups, or whatever, group buys that you're doing, is this the main reason for the small file problem, or the variance of file sizes, or the variance in compression algorithms that you were facing in your legacy system, or is that just due to other factors? I'm just curious.
Different factors contributed to different problems. Our small file problems were mostly from somebody trying to run a big join. It doesn't work. Developer, the first thing they would, or data scientist, or whoever is doing this, the first thing they will try is they will bump up SQL shuffle partitions configuration from 200 to 5,000. The job will run through, but what they don't realize is that now they're writing out 5,000 files at the end of this job without first reorganizing the data before dumping it to the disk. We also, variance in file sizes came from us loading data from, let's say, we were using Scoop to load MySQL data. And the way Scoop partitions data, if there is any kind of data skew on the primary key in the source tables, it will exist in your target tables. So this is where that was coming from. Variance in file formats. I think it was just we were using so many different tools. We were using Spark, Hive, Impala, Scoop. Each one of them has its own set of defaults, and nobody ever bothered to go override any of these defaults to make a uniform storage structure, right? So we had a little bit of everything.
Again, I completely understand where you're coming from about the fact that the different tools resulted in different things, different configurations, different default parameters. How bad was your small file problem? I'm just curious. I know, like, for example, in my past environments, whenever I had like these multi-tool problems, what ended up happening is I end up having like hundreds or thousands of these like 64K files or smaller generated. And they wouldn't run the compaction job or anything like that, and so we would just have these like millions of small little files. Of course, that just slowed down our Hadoop queries massively when we did that. I'm just curious if you were going through the same thing.
It's been tens of millions, close to 100 million of files on our cluster, and our name nodes had to be pretty beefy to deal with that. So by the time we were moving away from our legacy infrastructure, we were getting pretty close to having to deal with this issue rather than wanting to deal with this issue. So
Got it. Okay, so yes, so you definitely were suffering from the same set of issues. Okay, so in terms of the small file problem, so but then how does shifting to the cloud necessarily solve that problem? After all, if you're using the same set of tools, you would still technically have the same problem. So so it wasn't just about switching to the cloud, or I presume as you were coming from the legacy systems that you actually decided that you needed to go ahead and started migrating like the processes as well. So what were the different options that you had to consider to do all this?
So when we were migrating to the cloud, we actually, amongst other things, wanted to unify our tooling. We didn't want to support that many tools. So we were evaluating many options, and we settled on Databricks. At the time, it was Unified Analytics Platform. I think it's Lakehouse Analytics now. Danny, you should know the name better than I.
Yeah. It was actually a recent marketing push, by the way. Yes, it went from Unified Analytics to Unified Data Analytics Platform, and now the Lakehouse. But we are not a marketing scheme here right now, so let's definitely focus on the technical details here.
One thing that we were lucky with here is that we didn't really have much direct HDFS access anywhere in our workloads. All of our data was accessed through a Hive table interface. So all the queries ended up just going and first resolving the HDFS location in H catalog and then performing the underlying analytics. So what it allowed us to do is, as long as we keep those SQL interfaces, SQL, I guess, whatever catalog interfaces in place, we can go and change underlying storage format, file layouts, whatever we want to do, and still support our workloads. So it was a bit of a blessing for us that we had that. So it helped us a lot to move in a desired direction.
Right. So actually, that's something I definitely would love to dive a little bit on. So in terms of those options, you went through various different options and decided that one of the underlying factors was this SQL/Match Catalog perspective that was super important. Is it because of all your customers were like typically your BI tools, or is it because they're typically data scientists, or is it just because of the fact that you're intermixing all of these different things, and that's the reason why that ultimately became sort of a standard for you?
So we were intermixing it. We had Hive queries, and I would go work with Hive tables. When we have Spark jobs, the Spark jobs were reading data through Hive context through basically resolving at H catalog first. So it's just, this is what we inherited when we took over the system. Is this was one thing that actually was great and made this transition so much easier for us. So there were some, of course, there were some edge cases where people would go and work with HDFS directly and write Parquet directly into HDFS. But those were so far few in between, we could just manually transition them later.
Got it. So the folks that were still running good old fashioned pig scripts or whatever else, you can probably manually worry about them, and the rest you could go ahead and actually make it easier for them.
So yeah, so we looked at that, and because of that, we started actually evaluating multiple options. So one of the options that we considered was, well, let's keep our catalog as is and just copy the data to cloud and then point our catalogs to S3. So basically the table customers that used to be on HDFS will still be table customers. It's just going to point to S3 now. and theoretically everything should work. But what we quickly realized is there's like two fundamental problems with that. The first fundamental problem is cost. We would actually be doing so much data transfer between data centers because the data is in S3, but the actual workloads run in our data centers, that it will become cost prohibitive. And another problem that we quickly realized is going to bog us down would be eventual consistency of S3. And the fact that we weren't just moving the data for it to sit there, we were later on planning on moving some compute workloads, would mean that some data would be computed in one data center using one Hadoop vendor, while other data sets would be computed using Databricks in a different cloud, and trying to establish this cross-vendor, cross-cloud eventual consistency S3 storage is actually quite an undertaking. So we skipped that. And when we were looking at different ways to solve eventual consistency with S3, we quickly realized how many problems Delta solves for us if we were to use that. So, and that's what we settled on. We decided that we will go, and instead of just copying data once and then having tables point to data in S3, we would actually set up what I would call replication of data from our on-premise environment to S3. We would recreate the same catalogs in the cloud, but these catalogs now will have Delta optimized data under the hood stored in S3 versus all this various format unoptimized data stored in HDFS.
Got it. No, that makes a ton of sense. And so before I switch over to Max to dive a little bit deeper about the solution, I did want to talk a little about the nuances about eventual consistency in S3. So for anybody that's heard me talk about, Delta Lake, they would already know that I would just repeat the mantra of ACID transactions, the atomic transactionality. But I wanted you to sort of bring it real. Like, what were the issues when it came to eventual consistency for you that was actually going to, like, what were the problems that eventual consistency would cause, right? Outside of just cost, obviously there was the cost issues, but I'm just curious, like, was it because people were ultimately querying dirty snapshots? I'm just curious from your perspective, what were those factors that might have been coming into play here?
There are multiple things. First of all, there is no guarantee, right? I can write one job can write its data set from our legacy system into S3, and then the next job that launches will be reading the data that was just written, so they can get a dirty read. This problem becomes even more of a problem when you overwrite data, and we have lots of jobs that would, instead of just adding a new partition, they would overwrite multiple partitions worth of data, and that basically makes that problem so much worse. So we were looking at various options. Like we could have used, we looked at S3 guard, right, as one of the options. But the problem with S3 guard is it doesn't really work when you have multiple clusters. Like it works for all the writes happening from the same cluster, but if you try to share this S3 guard DynamoDB between multiple clusters, things start breaking. It wasn't a use case that was probably very well tested and addressed, so we shied away from it. Plus, the solution we ended up with was so much better and allowed us to just move faster in the further phases of our upgrade.
Oh, that's really cool to hear. So yeah, so the context of basically this data reliability really allowed you to focus on the real problems because you were sure of the transactional requirements, the protection of your data. I'm just curious, this is just more of a fun question. Did you actually have to worry about like deletion of entire partitions or tables, but then at least you were able to roll back to it like the old oops scenarios, or were you able to avoid most of those? I'm just curious.
We were available. We were able to avoid most of them by not using this approach. Basically, we looked at it, we evaluated it, we tested it, but we never tried it because we discarded it before we even tried it. Just all of the things we would have spent time solving.
Oh no, I meant like within Delta, like for sake of argument, that when you're running in Delta, like that you actually had to roll back a table because somebody did in fact delete a partition by accident. I'm just curious if you guys ever ran into that.
I think that actually will make it into a great transition, because Max had to roll back some changes that I accidentally deleted in Delta. So
perfect. Well, then, you know what? You're right. That is an excellent segue. Max, why don't you go ahead and explain how you rolled back some of Alex's stuff?
It was quite easy because it was time when Databricks released this, how to say, some sort like rollback to previous version functionality, and it was easy with Delta.
Excellent. No, it's a great call out. No, because in a lot of ways that's pretty much the reason why we had created Delta in the first place, because we end up having customers going like, "Dude, how do I roll back or undelete what I just did? Dang it!" It's like, you just deleted like 3 petabytes of data. Yeah, we're gonna have to find an easier solution than restore from tape or Glacier or whatever it was. So yeah, no worries. Okay, so in that segue, Max, like, let's talk a little bit more about, like, what you ended up on. We can start talking about, now you're in the cloud, now you're using Spark, now you're using Delta. Why don't you talk a little bit about like how you simplified the tooling, how you made that transition, things of that nature.
Yes. We had few problems. Yes. So first of all, we need to have tools that will be fully automated, because we don't want to stop business. We don't want to stop new table creation or something like this. So we need fully automated tools that will search our legacy catalog, find the data, newly created data, old data, modified data, and copy this data to new infrastructure. But also, we don't want to copy it as is. We don't want to move txt or rc or I don't know. So what we have Parquet files to S3, that we decided to make some sort of copy with converting to Delta directly. And how we decided to do this, it was a Spark application. Because why Spark? Because at the time, at the beginning of this thing, only Spark works with Delta. So of course it should be Spark, but what problems we had? First of all, we need to sync catalogs, because we have one Hive catalog and other one is Glue catalog, and we should keep all metadata up to date, because every day our users of our warehouse adding new columns, new tables, and that's why we decided to unify the process how we update both catalogs. It's a little bit different, interesting story, but finally we create a solution, like it's some sort of catalog as a code solution, where we add new database entities like tables or columns into some catalog. Not catalog, it's not actual catalog, it's some sort of meta store. Yes, and after that we deploy all changes to both sides, AWS and Hive. So when we had this synced catalog, we can actually start copy data, because we have table format on both sides, so, and on read and write. And I don't know what to add. Probably you want to know some details how we did this.
Yeah, absolutely. Yeah, so Absolutely. So I'd love to understand a bit better about how did you keep those catalogs in sync, because that is usually a problem for most people, right? Especially because I think one key point that we've sort of um, implied but haven't actually stated very clearly is that your migration to the cloud, it wasn't just like done in one full step. It's not like you just like, one day you're on-prem, the next day you're in the cloud and you've turned off everything on-prem, right? Like I guess I'm going to start with that problem. How long was that transition from the cloud, from on-prem to cloud? How long did it actually take? Because this obviously wasn't done in one day.
Yes, it definitely was done in months, not months. How it was? There was two problems. First problem, it was initial copy of this like a petabyte of data or something like this. And the next problem was daily incremental copy that we need because we migrate our computation step by step. So there was some time when we have, for example, half computation on old cluster and sync in the middle and other computation on new infrastructure. So how it was realized? First of all, we create some sort of configuration application that list our old catalog and new catalog and find all tables that available on both sides. So that means that if table available on both sides, we should copy these tables. Second part was when we have the list of tables that we need to copy, we started our data sync application, and it lists all tables in Hadoop and list all partitions and files that exist on HDFS. So it was like we use like checksum for updated data. It was combination of file name, modification time, and file size. So if all, so how we decide what we should copy? If this combination of file size, file name, and modification time was changed, we should copy this data to AWS. To track this information on AWS side, we have additional like metadata table where we wrote all copy data. So how all pipeline looks like. We list, for example, one table, collect all files information inside this table, check our metadata on AWS size, and if this metadata is different, we start actual copy. And we did this per table level, per partition level, and so that helped us to copy data incrementally with and on partition level, on table level. Then.
Got it. So then to make sure I'm on the same page, basically you have this data sync code that you created that allows you to look within HDFS to figure out what files changed for the tables that are listed, right? And then copy that data up to S3 accordingly. When you copy, oh, sorry, go ahead. And convert to Delta. So there's actually a couple of parts that I'd love to understand better. So for starters, when you got that list, like that typically was just more like, that was an easier read, I take it. Like it's just more like query the two catalogs between what was on-prem and what was in the cloud and make sure that they match. And whatever matches, i.e. good old-fashioned join, those are the tables that you'd look at. Then you listed out the files. So I'm just curious, like, for example, you know how with cloud object stores, listing files can be really, really painful, right? Did you have the same problem when you're working on-prem with your HDFS system as well?
No. With HDFS, we can list it quite fast because name node of a GFS consists all this information, so it really fast. Of course, we used some multi-threading to do it fast, because in one thread it will be super slow, but it was quite fast. We can do it. It's not S3. For GFS, it's okay.
Oh no, this is great. I mean, it's a great example of the difference between how the file structure worked when you're working with HDFS versus the cloud, and actually how you have to think differently because of it. So that's actually the only reason I'm calling this out. Okay, so perfect. So at least getting the files figured out was really easy and fast on the HDFS side. So perfect. Now you have the differences for each table. So then, did you like stage the data and then convert it to Delta? Like, how did you build that conversion? Like, were you using the convert to Delta statement, or were you doing something else? I'm just curious, how did you do it?
We just read this data using Spark and optimize. We have some sort of internal algorithm for optimization for small files, and we write it to Delta tables. It's like simple Spark application with it looks like very simple, but if you want to do it in really high speed with a lot of data, it should be really optimized. You should think about the number of output files, compress small files, or utilize resources for 100%. Like your application should not wait, just copy. So.
Right. So just to confirm, make sure everybody's on the same page, you're then copying your data sync tool is basically copying the files, the changed files, the new files, excuse me, from your on-prem environment for those tables, copies them over to the cloud. At that point, then basically it's just a Spark job that reads it, and then because you've optimized it and you've compacted so that way you're avoiding the small file problem, and then when you basically insert that data into your Delta table. So in your case, it's primarily, especially from that sync between on-prem to the cloud, it was primarily an append situation, right? Was there any concerns like CDC style of like needing to update or merge or anything of that nature?
When data was updated on on-premise cluster, we override full partition or full table. So we don't use merge because it's slow, first of all, and second, merge required actual data read from AWS, and we should pay for output traffic. So we just have like metadata. If metadata is not the same that we have in on-premise, we just overwrite full partition, and it's okay. It's quite fast.
Got it. Makes a ton of sense. Okay, so then this, you noted the fact that it was a transition over many months, right?
Initial copy was quite fast, but why it was something like 1 month? Because to make this copy, we should utilize our on-premise cluster, and we should not block jobs that related to business. So we start actual copy was started only when all daily pipeline was finished. So when cluster was free. That's why it was not like one huge copy for a few days. It was something like 5-6 hours per day. That's why it was 1 month. But it's okay because we have a lot of other activities during migration, so we have this time for preparing.
Got it. No, that makes a ton of sense. And so then, now that you've in essence caught up, like, have you completely migrated from your on-premise systems, or are you still using them? I'm just curious.
Yes, we completely migrated.
Oh, sweet. Okay, so then over a period of time, you basically made that slow migration, and then from that perspective now, and this is Alex, and I definitely would love your color commentary as well, in addition to Max. What ends up happening here is then you've now have multiple different toolings with different configurations, with different defaults, with small file problems. And then over this period of time, you were able to migrate to the cloud, build new processes and procedures. that you defaulted to basically Spark and Delta Lake, such that you could basically avoid or minimize, I should probably say, the small file problem. And now any concerns, any issues with transitioning people who are users of the data to using this new cloud/Delta Lake environment? I'm just curious, any feedback, thoughts of that nature?
I think there is any kind of transitioning. There will be, I guess, educational gaps. People need to understand them, but they definitely don't ask us anything about underlying storage of files or anything, because they're just working with tables, right? It was transparent to them, and that was the goal for us to get to that point. Yes, we did have a couple jobs that were writing to HDFS directly. I told you about those, and those guys had to be educated. Well, you're now writing to S3. Please don't write as text or per K. Use Delta. Why? Because, well, just use it, guys. You'll have optimized writes. You'll have acidity guarantees, and you won't have to deal with eventual consistency. So, amongst other reasons. So, and actually, maybe one thing to add here is that complex process that Max described in lots of words, right? I think it's easier to just look at the code, which we do plan on open sourcing. So others will be able to use this tooling, improve it, or adjust it for their own needs.
Oh, that's actually really awesome to hear. So yes, we'll definitely go ahead and be promoting that when it comes out, just because I feel that there are going to be plenty of customers that have practitioners and customers that actually have followed very similar footsteps as yourself, right? Which is they have to take their on-prem environments, they need to move it to the cloud, and there's a bunch of hiccups on the way. So then I guess, in the final bit of this particular session, are there any little tidbits or best practices or tips and tricks that you'd like to call out when you did that transition? Like, for example, like one example, what I mean by that is, for example, is like that little, our discussion about the fact that like file listings in HDFS actually is fast in all seriousness, and then switching to the cloud, not so much, right? In fact, that's why Delta places the list of files directly in the transaction log, so you can just query that, and that's significantly faster than asking S3 to list out all of its files. So I'm just curious, were there any other pros, cons, doesn't matter, but just tips and tricks or best practices from when you went ahead and did that transition yourselves?
I mean, one thing I can think of is if you're moving to an object store based data lake, just go with Delta. Just like we went it because I'm like, I might sound like, hey, I'm trying to promote something. I'm not. It actually did solve a lot of problems for us. And this whole concept of a transaction log on your per K files, it just unlocks so many features. And I'm pretty sure some of the features haven't yet been realized. So we chose it for one set of reasons. We were pleasantly surprised when we had to, let's say, share the data between different catalogs. Since Delta stores data in all of the metadata in the Delta's files themselves, the only thing it stores in catalog is a pointer. So what it allows us to do is we might have multiple catalogs, one used for development, one used for QA, whatever they are. But under the hood, they all point to the same underlying S3 Delta table. So when I change schema in one place, I don't have to now go propagate this schema across all these other environments, and it just works for us. You heard another great thing about it, like, hey, I screwed something up when we were doing this data sync. I actually messed something up in the source, and data sync replicated that. That's actually one good piece of advice. When you data sync in one way, make sure you keep your source data clean, right? If you delete something on the source, our data sync would actually also delete it in the target. Luckily, I timed it very well, because just like 3 or 4 days prior to that, Delta did come out with a restore feature that made it much easier. If it wasn't there, it would have still be possible, because we could still read the data from the past, overwrite it, and write it back into the same delta table. It's just made it much clearer. So yeah.
That's really, really cool. I appreciate the definitely call off to Delta. And for anybody that's listening to this session right now, no, we did not plan it this way. So, Max, did you want to add anything else? By the way, I noticed that you had unmuted, so apologies.
I just want to add that if you decided to move or upgrade your system, don't worry and do it with the new technologies. Don't move your old stuff to the cloud. There are a lot of new interesting technologies, frameworks, formats, and if you decided to switch to cloud, it doesn't mean that just move your old infrastructure, old data format, and all your problems to cloud. Leave it in old on-premise cluster and move with a fresh new technologies to the new infrastructure.
Max, that's actually really great advice. I've seen this happen time and time again where people, it's like, we'll just do the exact same like templates that we did for on-prem and we'll just apply it to the cloud and magically everything gets fixed. And you're going, not really. You're missing that entire elasticity independence thing that you actually need to have, right? So great advice. I did actually have a follow-up question though, if you don't mind. Especially because of what you called out, Alex, about the catalogs, like it's more specifically because you've built with everything with Delta instead of using Hive, and so like just like you noted, the catalogs are now pointing to the Delta table, but you only have to make the change to the schema once with the Delta table. But I'm curious, was there any change in terms of like the way consumers were using your tables now because of that fact, or any patterns that were changed because of such a thing?
One of the patterns that we're actually trying to push on people is changing how they develop, because previously the way they would test their changes is they would copy a table into a different namespace. Like they'll copy the table into their personal database. They'll change the job to instead of writing to original table to write to this other table. And now they're invoking it, checking the outputs, etc. That's basically the process. What we're unlocking now is telling people, hey, instead of having this one centralized catalog, we can have multiple catalogs. And our developers can, without changing the code of the job, just change the catalog definition and point the table to an alternate location, run their job as is without any code changes. You now have data in two places. You can still compare it. You like everything, well, you'll just deploy it, and then production catalog, it will point where it needs to point. So this pattern, it allows us to actually test the code that's going to go into production instead of testing a modification of a code that's going to go into production. Hopefully, I don't forget to change this name of a temporary table or wherever that is anywhere right before I deploy to production. So yeah, we were able to lose that intricacy of development process.
Oh yeah. I actually completely understand where you're coming from. In the past, where you basically not just have namespaces, but you had these massively long JSON files with all these different parameters that you would have to code in to basically say, okay, well, this is my test environment 1 in US East 1 versus, in my case, US West 2 or whatever else that I was using, and then if I forgot to do it in one place, and then all of a sudden I'm like accessing one like application in the wrong region, in the wrong testing environment or whatever else. So yes, it seems to simplify things a lot this way now.
Yeah, simplify is the keyword here, because fundamentally you're adding all of this additional interfaces, and you have to code around all of these additional interfaces in your app. But at the end of the day, you still, whether you change configuration or you change code, you're still pushing something different into a different environment.
Oh, no, that's great. Actually, I happen to be, this is a small shameless plug for myself, but I happen to be creating a Coursera MOOC, massive online course called Bringing Software Engineering Practices to Data and AI. And your example is actually perfect. That's exactly it. Like, how we're changing software engineering practices, simplifying them, making them easier because of simple things like this, right? So this is a wonderful example of that. Max, anything else that you'd like to add as well, from in terms of like how people have changed or how they develop or the consumer habits that you've seen?
I don't know. I already told a lot. What I want to say, yes, what I want to say is that with the new technologies, the development process is much easier because we have a lot of built-in functionalities that help us to store data properly, read data fast, join data faster, optimize on runtime, or something like this. That's why, cloud technologies, cloud frameworks, it's great thing. So use it.
Perfect. Actually, this is an excellent way to finish off today's session. Again, Max, Alex, I really appreciate you guys taking time out of your busy schedule to join for this particular session on migrating to the cloud or upgrading to the cloud. So again, thank you very much for taking your time.
My pleasure.
Thank you.